So we've added, subtracted, multiply, divide. Okay. Well, there's a couple of things we'll do here the next few days that will look like divide, but technically we won't do a division as we think of long division or something like that. What we're going to do here is we're going to take, say, a number 7 divided by square root of 3. Yeah, that looks like we're dividing by a radical. I guess we are, but we're not actually technically going to divide by the square root of 3, though. Here's what we're going to do. We're going to do what's called rationalizing the denominator. We're going to rationalize the denominator. Here's what that means. As you can see, my denominator, the bottom part I'm talking about, has a square root in it. Rationalizing the denominator means making it where the denominator doesn't have a square root in it. That's what that means. Make this expression where the denominator does not have a square root in it. Make it where the denominator doesn't have a square root. Now that doesn't say anything about the numerator. The numerator is going to have a square root in it, but the denominator is not. That's what we want to do with this. Okay? Here's how we do that. It's actually not terribly difficult. I'm going to take the 7 square root of 3. Well, let's look at what would happen if I multiplied the bottom by another square root of 3. Now, to make it a legal maneuver here, I have to do the same thing on the top. Right? If I multiply the bottom, I have to multiply the top by the same thing. So multiply the top and bottom by the square root of 3, and that's because that's the square root of 3 there. Okay? Well, let's see what that does. 7, and we multiply fractions. You multiply across. So we got 7 times the square root of 3 on top, don't we? I can't really multiply those other than put them side by side. But what about the bottom? Well, the bottom is square root of 9. And what about the square root of 9? It's 3. Okay? Here's my answer we're seeking when I'm told to rationalize the denominator, because notice what's changed here. The denominator, does it have a square root in it? No. The denominator does not have a square root. So that's what they mean by rationalizing the denominator. Make it where the denominator doesn't have a square root in it. Okay? All right. So if I did rationalize the denominator again on this one, let's do 4 square root of 5 over square root of 6. Looks a little bit different, and a little something else happens too, but what are we going to do to rationalize this denominator, you think? Multiply by the square root of 6, yeah. Just like over here we multiply by the square root of 3, here we're going to multiply top and bottom by the square root of 6. What does that give me? Well, that gives me on top, what does that give me on top? 4 square root of 30, okay? Yeah, because I can combine the 6 and the 5 square roots there. And then on the bottom, square root of 36. So I've got 4 square root of 30 over square root of 36, but just like previously, the square root of 36 is a nice square root. It's 6. But there is one other little fine detail here to finish this out. Do you know something else we can do here? Well, unlike before, now I've got this 4 on top. Don't these, can I simplify these? 4 and 6? Yeah, I can reduce those by a factor of 2 there. And so my final answer is going to be 2 square root of 30 over 3. Now, why don't I just go ahead, like I did there, reduce by 2? Why don't I reduce this, cancel that into that? Why can't I cancel the 3 into the 30 there? It's not in a square root, yeah. This 3, the reason I could cancel these is because neither one of these was in a square root. So I can cancel on them, but this one's in a square root, this one is not, so I can't go inside that square root because this one's not in a square root. That's why I didn't cancel over here, these 3's, because this one's not in a square root, that one is. Okay. All right. Let me give you one more of those. All right, rationalize the denominator of the square root of 7/10. Rationalize the denominator there. Which at first glance you may be thinking, well, I don't have a square root in the denominator, but I do have a square root in the denominator here because this is the square root of all of the 7/10 there. In other words, can I break that down to be square root of 7 over the square root of 10? That's what that means. So I do have a square root in the denominator. So I do have to rationalize the denominator as it tells me there. How do I rationalize that denominator? Well, multiply by square root of 10, top and bottom. Then multiply square root of 7 times square root of 10. Square root of 70, yeah, I would multiply those inside there. Bottom, square root of 10, square root of 10 is square root of 100. And then square root of 100 is 10. Anything else? Anything else I can simplify there? No. Again, I can't go that 10 and that 70 because that's inside the square root. That is not. So that's it. That's all you do on that one. Questions or concerns?